Okay, let me give you guys some practice now. In one of the earlier videos, I gave you a formula for a pendulum here, and asked you what would happen if we were to double the length of the string. How would that affect the time that it takes to make one swing, the period t? And then we started here, and then we rearranged it, and got to this stage here. And once we were at this stage here, we can say that, oh, the period is proportional to the square root of the length. Okay, and then well, once we're here, we can say, oh, what would happen if we were to double the length? If we and then we would make the length as 2L. So this is our old system here, and then this is our new system where we put where the length is 2L. So we will put it into here. So this is our new length here. Okay, and then this is our new, this is our old here. We would rearrange this somehow so that we can express it in terms of the old system. Okay, so from this here, you would use your indices here, and then get to this stage here. So basically, you've got this thing times this thing times this thing here, and then we would then move this in front. Okay, so it becomes this. So you've got this thing times the old system here. So remember, this is our old system here, and so this whole thing here represents our new system. And this here was our old system, where the length of the pendulum is L, and this one here, the length of the pendulum is 2L. Now, by us expressing it in this way here, we can see that, well, the new time is this much times the old time. So from this, we know that by doubling the length of the string, we know that the period will increase by root 2. Okay, well, anyway, back to this thing here. Now, my question now is, what do I need to do to the string, to the length of the string, in order to double the period of time? So now, so here we've got a system where you have the length of the string as L, and it takes the time of t to make one swing. But now I want it to make, well, I want the period to be twice as long. What should I do to the length of the string? Should I increase it by 2? Should I increase it by 3? Or should I square root the length of the well, what if I want the pendulum to take twice as long? What should I do to the length of the string? Okay, so press pause. Oh, wait, before you press pause and have a go. Before just a clue here. Before we came up with something like this, K root L, and then we came to the conclusion that T is proportional to the square root of L. You see, by you doing this here, you're varying T, you're varying L, and see what effects it will have on T. But now in this question, you've got to somehow express it so that L is proportional to something involving t, because you're varying the t, and see how that affects the L. Okay, well, anyway, do whatever you have to do. If I want to double the period here, what should I do to L? Okay, so if this were to increase by, well, if I double t, what would happen to the length of the string? So press pause and have a go. Okay, so to do this here, we ultimately want to express L. Well, we want to get to something like this, something involving t. Okay, something we want the length of rearrange this formula here so that you make L the subject. Okay, so here divide both sides by 2 pi, so t over 2 pi equals root L over G. Okay, and now square both sides. So it will be t squared over 4 pi squared equals L over G. And now times both sides by G. So you've got G t squared over 4 pi squared over L. Oh, well, sorry, equals L. Just to simplify this, I'm just going to switch these two around. So I'm allowed to do this here. Hang on. 4 pi, because if an elephant equals a giraffe, I can say a giraffe equals an elephant. So it's pretty much the same thing. Okay, so here because because we are varying t. We don't really care about g. We don't really care about the number 4. We don't really care about the number pi. So basically here you've got this bubble times this bubble here. Let's take t squared out. So it's like this. Hang on. So it's g hang on, over 4 pi squared times t squared. Now, so here you've got this thing here times this thing here. Now, I'm only varying t, so I don't really care about this whole thing here. So I'm just going to give a new variable name. I'm going to call it k. K t squared. So now the length. So once we are here, we can actually make the statement of L being proportional to t squared. Okay, we can make this statement here. So now we've got a system where, well, when you have the length of L, it takes t time to make one swing. Now let's set up a new system where we have well, we don't know what this thing here is, but we're gonna double the time. We're gonna, well, our new period will be 2t. So so let's put this into this t here. Okay, so this is our old system. Now our new system, the length of the string equals k, and then we are putting 2t into this t here, because at the moment it's t squared, but our new time will be 2t. So we're going to put 2t into here. Okay, we are actually putting 2t into that thing here. So this is our new system here. This is our new system. This was our old, now new. Okay, now we want to express a new system in terms of the old one, so that we can see, so that we can compare it to the old one. Okay, so now by using indices here, this equals k t squared t squared. Okay, because when you have ab squared, you well, when you have a times b squared, that becomes a squared b squared. Okay, so so now you've got this thing times this thing times this thing. Move this in front so that we can express, well, we can express a length in terms of the old length, and you will see what I mean later on. So here you see our new length. You see, this is our old length here, because look, old length here is kt squared. Okay, now you've got here kt squared. So yeah, so you've got k. Well, this is our old here. This is our old. Well, our new length is 2 squared of the old length, which is, hang on, which is 4 times the old length. Well, the old length being this t squared. You see, if you were to double the period, then look, the new length will be 4 times the old length. Okay, so this is your answer here.